Hello and welcome to the opening day of our second annual Green Roofs and Walls of the World Virtual Summit 2013. Today we have the pleasure of sharing the recent findings and postulations of keynote speaker Aditya Ranade, who is a senior research analyst on the Lux Research intelligence team leading the Sustainable Building Materials Intelligence Service. Probably most of you have never heard of Aditya before. I know I hadn't until October of 2012, but his research report and the title of his opening keynote address, Building Integrated Vegetation, Redefining the Landscape or Chasing a Mirage, created a huge stir within our industry when it was published last fall. You'll be very pleased to know that Lux is predicting a $7.7 billion global market by 2017. Armed with an engineering degree, MBA, and PhD in macromolecular science, Aditya has enjoyed a long and varied career in science-driven innovation and emerging technologies. He's previously authored reports on building integrated photovoltaics, sustainable architectural coatings, and global green building hotspots. In his presentation, Aditya examines the key drivers and the barriers for growth in our green roof and green wall market. He says the environmental benefits of building integrated vegetation remain hard to monetize, but with key cities around the world putting incentives in place, a significant market opportunity is emerging. I know you'll appreciate the in-depth research reporting, projected growth, and upbeat tone that it sets for our Virtual Summit 2013 and for the future of our industry as a whole. Enjoy.
Welcome to today's webinar on building integrated vegetation. Good morning, I am Aditya Ranade, Senior Analyst at Lux Research. I lead the Sustainable Building Materials Intelligence at Lux Research. In Sustainable Building Materials, we look at a variety of technologies that reduce the resource footprint of buildings, like energy, water, environmental footprint. So obviously building integrated vegetation technologies like green roofs and green walls is a great area of interest for us. We have covered it for the last 2 years, looking at technology, policy, and financing aspects of this segment. We feel that this technology space is really at crossroads. 10 or 15 years ago, it was just a green niche or curiosity, but today it's a real market with large companies and startups all vying for attention, competing, and sometimes collaborating with each other. So now the question really is, what is going to happen to this market 5 years from now? Where is the growth going to be geographically, and how can companies win? And what are their value propositions? So we're going to discuss all of that in this presentation. So let's dive right into it. As was probably apparent in my introduction, the central question that we're trying to answer in today's presentation is whether building integrated vegetation is a real market or it's just another green niche or curiosity. Before we do that, let me walk you through some background on Lux Research. Lux Research focuses on science-driven innovation and emerging technologies, such as those listed on the right-hand side of this page. Our clients are globally located, and the executives within those clients have global responsibilities. Our analyst team is global as well, scouting across the globe to find technologies, applications, and market opportunities that speed up our clients' innovation strategy. In this talk, we're going to focus mainly on sustainable building materials and efficient building systems. In sustainable building materials as well as efficient building systems, we look at the resource footprint of buildings and the technologies that enable reducing that footprint. As is probably obvious to many of you in the audience, the rapid urbanization that has taken place over the last 4 or 5 decades is the major driver of a number of building technologies that we cover in these two services. However, this urbanization has also resulted in a number of specific hyperlocal environmental challenges. A few examples: urban heat island effect. On the left-hand corner of this page, you'll see the heat map of the Boston area, and although it's the same topography, you see the heat concentrated in the most densely populated areas of this metropolis. On the right-hand side top corner, you see a picture of the Los Angeles skyline, and the effect of particulate carbon and smog is very obvious in that picture. The bottom picture on the slide shows the stormwater overload of sewers in Mumbai, which every monsoon results in significant floods and brings the city to a screech. So building integrated vegetation has moved beyond being looked at as another way to increase livability or urban green space. Now, cities are looking at it as a means of mitigating some of these very specific hyperlocal environmental challenges, some of which I pointed out in the last slide. So how do we define building integrated vegetation? So Lux Research has taken a very careful look at all the different technologies that involve vegetation in urban areas and buildings, and come up with this term, building integrated vegetation, which includes any exterior or interior building material that incorporates vegetation for aesthetic, environmental, energy efficiency, or food security purposes. The most commercially dominant of these are green roofs, and a schematic layered structure of an extensive green roof is seen in the left-hand corner. In the right-hand corner is a green wall, or vegetated wall, if you will. And the bottom shows a vertical greenhouse in a double skin facade. Vertical greenhouses or vertical farming are not commercial yet. There have been a number of demonstration projects, but today's talk is going to focus on green roofs and green walls. So I alluded to the fact that green roofs and walls have certain benefits that help mitigate some of these environmental challenges. Now, are these quantifiable? I'm going to list some of them. Number one is thermal insulation. So green roofs and walls reduce the solar heat gain via shading, as well as add thermal mass. Some of the measurements that we have observed are from a study by National Research Council in Canada, and they reported a reduction in air conditioning energy demand from 7 to 1.5 kilowatt hours per day, and this is pretty significant. So they started with a roof with standard polyolefin roofing membrane and expanded polystyrene, and after the green roof retrofitting, they observed nearly 66% reduction in the cooling energy demand, and most importantly, this was during the peak demand time. So the economic benefit actually would be even greater in geographies with a tiered pricing structure. One major barrier to demonstrating this value is the reliance on steady-state R-value by designers and architects. So without in-field data or very good modeling simulations, the conventional designing parameters will underestimate this value. Stormwater management. This has been a big driver for green roofs. And a study from Nanyang University in Singapore reports 50% reduction in peak runoff. So the economic value is really contingent upon the existence of a stormwater tax and any benefits that the building owner might have by installing a green roof. Carbon fixing. Like any other photosynthetic organism, green roofs and walls absorb carbon dioxide and convert it to oxygen and glucose. The economic payback here is contingent upon the existence of a carbon price. After three benefits that are quantifiable in terms of economic payback, let's talk about two other benefits that are not. The first of these is removal of airborne pollutants such as nitrous oxide, sulfur oxide, and particulate carbon from ambient air. Green roofs and even more than green roofs, green walls have a significant benefit in removing NOx and particulate matter. However, the economic benefit is not obvious. This is highly dependent on city level regulations to address ambient air pollution. So building codes in cities like London and Copenhagen are trying to mandate it, and that may drive the adoption of green roofs and green walls. And the last benefit is acoustic insulation, pretty significant, reduction of sound by 8 to 18 decibel levels. However, there is no economic benefit. This is a nice to have for most building owners, and it really doesn't affect the bottom line. So it's probably obvious to you by now that these value propositions are disaggregated. Unless they're taken together, it's difficult to justify very expensive green roofs or green walls. Let's take mitigation of urban heat island, for example. Green roofs and cool roofs both result in cooling energy savings, comparable performance, but cool roofs are significantly less expensive by an order of magnitude in some cases. Let's look at stormwater management. Why would somebody spend $4,000 for a green roof when they can buy a 53-gallon rainwater harvesting tank for 10% of that price? Air pollution removal. Green walls are very, very expensive, but photocatalytic coatings can have a comparable performance at a fraction of that cost. Green walls are, of course, far superior in removing particulate matter from air, and this is where photocatalytic coatings are not so useful. So when looking at these benefits individually, it's apparent that a building owner would go for these alternative technologies and not building integrated vegetation. So really these technologies are driven by thought leaders, city governments who really appreciate all these different value propositions and are driving it via various supportive policy measures. Who are these thought leader cities? We have identified 63 cities all over the world, 15 of them in North America, 2 of them in South America, 25 of them in Europe, and the rest of them in Asia Pacific. Few examples: Portland, Oregon, very, very attractive cash rebate program, up to $54 per meter square. So this forms 10% or more of the installed cost for green roofs. London, in addition to a discussion of including green roofs in the building code for air pollution removal, there is a significant stormwater tax reduction already in place. Copenhagen has announced a green roof mandate in 2009 where all buildings above 1,000 meter square floor space have to have a green roof. Sydney, green roofs and green walls, buildings that have those receive significant exemptions from city development levy. Tokyo, again, there is a green roof mandate for buildings above a certain floor space. Beijing has announced very, very ambitious targets. They would like to install green roofs on 30% of the flat rooftops by 2030. And supporting policy measures are popping up in the most unexpected places. Bogota, Colombia has a green roofs requirement that is slated to go into the city building code by 2015. So as a result of these specific cities driving this market, today building integrated vegetation is worth $5.5 billion in 2011. Out of this, green roofs form a vast majority of the market, with installations being 11 million meter squares in 2011. And green wall installations stand at 28,000 meters square. So as a result, some of the pioneering companies like Zero Floor, Semper Green, and Zinco have grown in size over the past 2 decades. The revenues for Semper Green USA alone is $5 million per year. Zero Floor has, since 2002, installed 2.5 million feet square of green roofs all over the world. Large building materials players have taken notice of this success, and they are entering the building integrated vegetation marketplace. Some have taken the approach of supplying components. Sika Sarnafil supplies waterproofing membranes, root barrier membranes, and drainage layers, while some other firms have taken the approach of building the systems themselves. Skyshape vegetative roof systems from Firestone Building Products is an example of the second approach. And in addition to the pioneers growing and larger players entering the marketplace, new designs and technologies continue to arrive on the marketplace. The right-hand side corner on the bottom shows a green wall with alternative layers almost of vegetated sections and white TiO2 containing photocatalytic coatings. This system is invented by Serra Casa Ceramica. It's a Spanish company. So the idea here is to combine the air pollution removal capabilities of photocatalytic coatings at a significantly low price compared to vegetated walls, and to use the byproducts of the photocatalysis, namely nitrates and sulfates, as fertilizers for the vegetation. So you're reducing the cost and you're reducing the problem of these nitrates and sulfates going into the groundwater. Another innovative design that also comes from Spain is combining a low carbon cement technology using magnesium phosphate with a living facade. The interesting thing about this is the magnesium phosphate, in addition to absorbing carbon dioxide, also has pH and surface roughness such that it increases the growth of microalgae, lichen, and moss. So these walls are vegetated on site. Lux Research evaluates a number of such firms regularly. We profile 100 innovative companies in each of our services every year. One example in the building integrated vegetation space is a small company out of United Kingdom called Biotecture. Biotecture makes pre-vegetated cladding systems and irrigation systems with active control for exterior walls and facades. They have an impressive list of corporate customers, including Veolia, BMW, and Barclays. And their business model is to sell directly to contractors and project owners. It's in introduction stage. Their production capacity is about 1,200 meters square per year. Their revenue in 2011 was nearly $2 million. And the company is funding its growth via its own cash flows. It's profitable. Performance metrics are in the process of being measured. They have a research program ongoing to measure the thermal insulation and diesel particulate removal efficiency with the Imperial College of London. So even though the installed cost is high, this company is getting some traction. So our take on this company is a wait and see. So when we evaluate these companies on a scorecard, we have a rating from strong positive to wait and see to caution and strong caution. And this is an indicator of whether our clients or similar companies should engage with this company. So our recommendation is that companies developing novel self-supported porous media should engage with Biotecture for demonstration projects. So we have seen that despite some of these disaggregated value propositions and barriers to adoption, select cities are driving this market, and a number of companies have been successful commercially. So what does the future hold? How large is this market going to be in, say, 5 years? In order to determine that, we used a logistical curve model. The most important variables here are market size at maturity or saturation point, coefficient of external influence, coefficient of internal influence. Now, let me explain a little bit what I mean by these three. So saturation point is, in case of cities that have explicitly stated goals of, let's say, 30% of flat rooftops to be greened or 15%, we directly use that number as the saturation point, assuming a certain growth rate of new construction, which is usually in line with GDP growth in that country. In absence of that explicitly stated target, we assume about 15% of all the flat roofs suitable for greening. This is taken into account how many rooftop HVAC systems are in place, how many buildings are using building integrated photovoltaics or rooftop solar panels. The two other important variables are coefficient of external influence and coefficient of internal influence. So external influence means any external factor that will prompt a building owner to make a buying decision. So this would include tax credits, any supportive policy measure, or regulation such as building code. Coefficient of internal influence essentially captures the power of word of mouth growth in a given market segment. So this really stresses the importance of early adopters, and it's indicative of a momentum, internal momentum in that market segment. So when we do all of that, this is what we come up with. The cumulative green roof installations double from about 100 million meter square in 2011 to 200 million meter square by 2017. When we look a little more deeply and look at new installation, we realize that the market as a whole is slowing. So the new installations will peak to about 16 million meter squares by 2012 and stay between 16 to 18 million meter squares by 2017. And the green roof market size in dollars, again, shows a similar trend with the market size, annual market size actually reducing a little bit between 2015 and 2017 because of the cost reductions in green roof systems we are forecasting. But what if we look into each of the three regions we are looking at, Europe, Americas, and Asia Pacific? Is the picture same or different? In Europe, we predict a significant slowdown. And this is mainly due to the markets in Germany and Switzerland, which we believe are close to saturation point, and the slow rate of new construction is not helping either. So unless new cities come on board, like Stockholm or Zurich or Malmo, we are pretty much looking at a flat market in Europe. And if the macroeconomic environment worsens, if the Eurozone breaks, then we could be looking at an even more serious situation in the European market. And let me repeat this, because the last 2 decades, European market has really driven building integrated vegetation. But we believe it's time for a paradigm shift. The market is moving from Europe to North America and Asia Pacific, and the companies must adjust their entry strategies accordingly. The Americas, coastal cities in US and Canada are going to propel the green roof installations to 5.7 million meter squares by 2017. So cities like New York, Washington, D.C., Toronto, Vancouver, Chicago, and some of the newer ones like Bogota, Colombia, should see a significant growth. We're starting from a smaller base in the Americas compared to Europe, and this shows all the features of a market in early stage growth. Asia Pacific, the growth is going to be driven by Shanghai, Tokyo, and Singapore. And assuming no new cities come on board, we are predicting 4.7 million meter squares by 2017. Now, looking at the typical adoption cycle of 2 to 3 years, if you're not in Asia already, it's probably too late to enter these cities. But there may be newer cities like Kuala Lumpur or Mumbai or Osaka, and if they come on board, then we are looking at a market size of 7 million meter squares in 2017. So we would urge the companies who are listening to this, if they're interested in Asia Pacific, to look at these newer cities. Green walls. This is a very, very, very nascent niche right now, but slated to grow 16 times over the next 5 years. So we're looking at cumulative installations of 4 million meter squares by 2017. And the growth is there across all the regions, Europe, Americas, Asia Pacific, they're all growing. And right now there exists a great variety in terms of the types of green walls, the types of suppliers. So if you're interested in entering the green wall market, the time is ripe. The next 5 years should see more of a consolidation and reduction in the number of players and the number of designs. So the time to enter and become an incumbent is now. So what do we recommend to different types of stakeholders in the value chain? We are recommending that the building material supplier should find credible system integrators to supply when entering a new city or country. You should really have the mindset of a sniper rather than a carpet bomber, because these markets are driven by individual cities with hyperlocal challenges. So you must find system integrators or customers who are strong with established channels in those individual cities. So far, the choice of vegetation has not been sophisticated, but we recommend that makers of vegetated mats and blankets should determine the best vegetation for each value proposition. It's obvious that air pollutant removal, thermal insulation, stormwater retention, each of those individual value propositions will have a certain type of vegetation suitable for those purposes. We recommend that the city should clarify their priorities for promoting building integrated vegetation and tie them to these specific performance metrics. And system integrators and architects and design firms should focus on more in-field performance data, better estimates on economic payback, and better modeling capabilities in absence of in-field measurements. As this market becomes mainstream, the economic metrics are going to become important, whereas up till now they have not been. So we really see the market shifting from Europe to the Americas and Asia Pacific over the next 5 years or so. And we predict that the building materials companies are going to move away from just repurposing standard roofing membranes and drainage fabrics to developing special grades and waterproof membranes and geosynthetic fabrics with multifunctional capabilities, specifically designed for BIV. We also predict that the design paradigm for BIV is going to shift from a carefully cultivated garden to a meadow that doesn't require very much irrigation or weeding support. And this should result in significantly reduced costs and further propelling BIV into the mainstream. And finally, we will see BIV technologies increasingly integrate with other innovative building materials like photocatalytic coatings or solar panels. So building integrated vegetation is at a very interesting turning point where there are shifts in the geography as well as shifts in design. And the companies who are able to navigate both these changes successfully will thrive in this atmosphere. I hope you enjoyed that presentation. The three main messages that I want to leave you with are, for success in this space, number one, location, location, location. Like in real estate, building integrated vegetation is all about hyperlocal needs and how your technology can serve those. This market is really driven by a select few cities. So it's really critical to project and forecast what cities are going to come up with supportive policy measures in the next 5 years. So I would urge you to look at Kuala Lumpur, Osaka, Stockholm, Mumbai, cities like that, perhaps Bogota or Lima in Peru. Number two is the credibility of your partners. Green roofs and green walls, they are part of the structural envelope of a building and very, very important to the physical integrity. They typically have 20 to 40-year lifetimes. So you should find partners which can provide a single source warranty. So partnering with larger contracting or building materials companies is probably a good idea to establish credibility. Nobody is going to give you a project and trust you with their roof or wall if you're just a 5-year-old company. So the quality of your partners is extremely important. And last but not the least is to think about the value propositions for each of your projects. The disaggregated value propositions that I mentioned. You should really think about for each of the cities that you're going into, what value proposition is driving the adoption of green roofs or green walls in that city. Is it removal of smog? Is it the carbon price? Is it meeting food security needs? Is it reducing air conditioning bills during peak demand? And once you've identified one or two or three of those, then you can see where your technology can help you differentiate. So if you know where you want to market your technology, who you want to partner with, and what are your competitive differentiators that address those value propositions, then you'll be in good shape. I thank you for your attention and happy to take any questions at this time.